So in this chapter here, we're going to cover section 7.1 and 7.2 this week. The first section is on lengths and perimeters. Now, we're not going to be asking you here the perimeter of a rectangle. I'm sure it'll pop up at least once, but after that, you won't see me giving you the same question over and over again. But still, anyway, definitions are important here. And I just want to make sure that you're familiar with some properties of circles especially. So if I take a look down here, here's a couple of circle formulas, and they represent the circumference or the perimeter of the circle. So these are a couple of formulas that I expect you to know coming into the course. If you don't remember them, well, here's your opportunity just to have them handy. Notice that you can write the circumference in terms of the diameter or in terms of the radius. When you're using your calculator should have a button called pi. If you can't locate your calculator pi button, or if you're using your phone, for example, and doing a calculation, you can always just type pi to several number of decimal places. In this case, pi is represented to 5 decimal places, but that's more than enough for typical engineering calculations. In terms of what we're going to do with formulas, we'll see a lot of questions in the first part of the chapter involving shapes and rectangles, semicircles, quarter circles. So let's take a look at some questions and just start going on this material. If you flip ahead to page 5, there's a whole bunch of exercises here, and I've just, in advance of teaching the course, I just chose a half a dozen questions, and I said, okay, these are a good mix of questions to cover in class. So for this lesson, please have your calculator handy and help me with the calculations, as I have not done the calculations in advance. As per usual, I want you to do the calculations with me and with your classmates. So we're going to go, and I'll just give you a list of questions if you want to just jot them down on a piece of paper. I'm going to be going through them in detail shortly. We're going to go through questions 5A I should say, 7, 9, so 5, 7, 9, and then on the next page, I selected question 14. So 14 has 2 mini questions, and we'll cover each of those questions separately. So that's basically it. So if you count them up, I believe that is 5 questions. So let's take a look at the first question and just get going on this. I kind of put emphasis on questions involving circles or parts of circles because those are the things that usually people have challenges in terms of their calculations. In terms of what I cover in class, please keep in mind that what I'm showing you is just a sample of questions. It's my expectation that you try all the questions. If possible, just try all the questions. If you are under a lot of pressure and this week and you don't have a lot of time to do these questions, but the bare minimum, as with other chapters, is the starred one. So here, anything that has an asterisk beside it, those are the ones that are bare minimum, like in terms of what you should do. And that's it. So let's take a look at 5A, which is our first question. So it says here, find the circumference of a circle if it is 4.5 inches in diameter. So let's just zoom in on that for a second. So if you like, you can in the chat tell me what would be the formula that we could use for this one. So the circumference would equal, what's the formula for the circumference in terms of the diameter? Okay, so James's formula, thank you, James. James's formula applies well to this one here, which is the radius, 2 pi r. In this case, the question is in the diameter, so we can use the alternative formula. James can use that formula just as fine. He would just have to divide the diameter by 2. So I'm going to use that one if that's okay, but both formulas are more than adequate here. So the circumference is going to equal pi times 4.5 inches. I'll try my best to include units when the formulas are simpler. If we get some really, really complicated questions, I might not write the units as I substitute the variables, just for the sake of like the space on the page. Also because there's just going to be so much writing. But what I will always do is try to keep the units consistent. And I encourage you to do that as well. So if there's a question that has units that are all over the place, try to tie all the units together and be consistent. Anybody have a value on that for 5A? We're going with 3 significant digits if possible. So how many inches is that? Anybody have a number on that? Pi times 4.5? Thank you, James. Thank you, Nicolos. That's good to go. So 14.1 inches. Perfect. Nothing miraculous here. We're just doing something very straightforward to break the ice. I didn't highlight 5B, but I could quickly say that one as well, if that is something that you would like to see. So 8 centimeters in this case. And I have my calculator too. So let me grab my calculator. Unless someone has done that already in the chat, let's do that too. Perfect, thank you. Okay, so there you go. I did the other one as well. Might as well. I mean, it's copy and paste pretty much. Let's move on to something a bit more dangerous. Hopefully the next question has some type of complexity beyond a circle. Ooh. Okay, so this is nice because it has information regarding a circle, but also it's relating to something involving distance in terms of speed, distance, and time. So we're not going to deal with speed, distance, and time for this question, but it does have that aspect of revolution or rotations per minute or something. So in this case, we have a tire that is 28 inches in diameter. How many revolutions must it make for the car to travel 1 mile? So if you ever looked at a tire on a vehicle and you've wondered, I wonder how many times that thing turns around when it covers a certain distance, like a kilometer or a mile or what have you. So anyway, let's find out what the what the circumference is of the tire. So that's the first thing that I would do. So what is the circumference of that tire? Anybody have a value for that? Thank you, Marco. Okay, we got differing numbers there. Is it 96 or 92 at the end there in the decimals? Okay, the tiebreaker is 96. Sounds good to me. 87. Because this is not the final answer, I'm just going to put more decimals on this one. 9, 6. Okay, 9/6 is fine actually. Forget that. Change my mind. All right. So that's how many. That's the distance it covers in one rotation. You will have to dig back into your unit conversions sometimes for these questions. So you might not remember this, but I'll just remind you that 1 mile is equal to how many feet? Does anybody remember how many feet are in a mile? 5,000 something. Who remembers how many feet are in a mile? I know this is going back into the archives. It's been a couple weeks since we've done any unit conversions together in class. That's right. Thank you, James. Thank you, Sheldon. Welcome to the party. 5280. Okay, so 5280 feet. So the thing that I'm emphasizing here is that it's feet. So it would be of interest to us to convert this answer for circumference into feet. So we can divide by 12 to do that. So what I'll do here is I'll multiply by 1 foot for every 12 inches. Or in other words, just divide by 12. Just dividing by 12. So this conversion here, I can just stick that in there because remember, this fraction equals 1. So when I multiply the 87.96 inches by 1, I'm not changing it or wrecking it or doing anything weird to it. I'm just converting it to feet. So if we divide by 12, we get 7.330 feet. So now it's a matter of figuring out how many rotations there would be in this tire to cover 1 mile. So anybody, what do you think in the chat? What should we do now to find out how many rotations? Yeah, just divide the two answers. That's right. I don't want to be fancy here. I'll just do it like that. 5280 feet divided by 7.330 feet is 720. 720. I got a couple 720s. I'm not going to argue with you. You got the right answer. All right. Now, some of you might be wondering, is there a more formal way of doing this? Could I use like unit conversions or something, how I did with the previous chapters? Absolutely. Let me show you a more formal explanation, okay? What you can say is that we have, let's see here, one rotation is worth 7.330 feet. And if I multiply that by 5280 feet, then the feet cancel and you get 720 rotations. I'll just say this here. This is fancy. You don't have to say that, okay? You say this. Most people in this audience are going to be like me too, like common sense. That's common sense, the blue thing, okay? The stuff underneath is me just trying to motivate you with unit conversions. I'll just say fancy here. I'm going to gray it out so you don't like emphasize it or like really dwell on it. But all I'm trying to say here is that in the event that you're not sure how to process the numbers, you can use the methods for unit conversions and apply them here because really they tie together nicely. So there's a couple of questions that we can start off with. Let's take a look at some more interesting shapes and hopefully something a bit more entertaining than a wheel rotating. So there's the next question. Which of these two figures has the larger perimeter and by how much? So I'll give you a little bit of time to think about this one. I want you to think about which of these two figures here, the plus sign or the square, which of those figures has the larger perimeter? So let me know in the chat. Do you think that the left one, I'll just say you can say square or plus if you believe that one of them is larger? Okay, some more people in the chat. I want to see some answers. Some predictions. Okay, so based on my little experiment, it appears that people who have their name that starts with the letter N predicted the right answer. So if your name is, Nicolas, you just broke my hypothesis. So they're both the same perimeter. They're both the same perimeter. Okay, they're both the same. They both have the same perimeter. They both have the same perimeter. So I'll convince you of that. If we take the square, what's the perimeter of the square? Well, we're going to go through it right now. What's the perimeter of the square, everybody? What's that equal to? 120, okay? It's 30 times 4, right? 30 centimeters times 4. Okay, so and now I need to convince people that didn't see that why it's 120 as well. Well, let's just add it up. Let's just count them up, okay? Just count them up with me. Each of these line segments is worth 10, okay? Each of those is worth 10. So I'm going to start counting. Ready? 10, 20, 30, 40, 50, 60. I'm halfway now. See that? 70, 80, 90, 100, 110, 120. Now, it's a very funny optical illusion, but here's the interesting thing. You see this thing here? Imagine if you folded it out. So you took this purple thing here, this guy here, and you folded it out, and you unraveled it. Do you see how it turns into a square? So there you go. So the nice thing, the visual exercise here is that the visual exercise here is this. When you look at a blueprint or a diagram, sometimes you'll see complex figures like this. And then you'll say, well, I need to quickly estimate. For example, let's say this is a plan view of a room, and you're like, well, how many linear feet of wall is that? So if you're looking at the perimeter of it, you're like, I want to put drywall on this thing. How many linear feet around is the room? Some people will not immediately see that you could just unfold it into a square and then get a quicker estimate. Anyway, we're not going to do that much abstract thought today. Most of the questions that you're going to see today are just going to be chopping up figures into pieces and hopefully finding out patterns or smaller shapes. So let's try a question that's a bit more just hands-on and not as abstract as the previous one. So find the perimeter of the two figures. So there's two figures here. I'm just working on this one for now. So let's just scroll up there. So there's a hint here from the author, which I'm not really going to discuss too much. I just want to go through it with you in a systematic way. So when you're finding the perimeter of this figure, the first thing that I would do is think about the easy stuff. Always go with the easy stuff first. So everything that I'm highlighting in purple is easy, hopefully. Can someone tell me what the purple quantities add up to? What do all the purple lengths add up to? 38. Can someone confirm? Because I'm not doing the math in my head. I'm typing stuff now. So can someone confirm 38? Okay, I got 38. Thank you. And we have one more portion here, which is this semicircle. Okay. What is the perimeter of the semicircle? Well, I don't know what the perimeter, I don't have the, oh, thank you, Nicholas. I don't have a formula for a semicircle, but what I do know is that a circle, the perimeter is 2 pi r, or yeah, I'll say pi times diameter, actually. You could use 2 pi r, or you could use pi times diameter. I'm going to use pi times diameter, but because it's a semicircle, I need to modify the equation. I'll divide the equation by 2. So in this case, we're not going to use the letter C because it's not a circumference. I'm just going to say that's equal to S for the semicircle. You don't have to give it a name at all. Like these linear portions, you can call it L for linear. Like these letters that I'm using, these variables are arbitrary. They're just helping me communicate, hopefully, better. In any case, what the heck is the diameter of this semicircle? Can someone tell the class what the diameter of the semicircle is? It's 8. Thank you, Tamirlan, and thank you, Nicholas. Yes, it's 8 meters. Let's confirm for the class why it's 8 meters. So this is 8 right here. That's what the argument is. Well, it won't be half of 14 necessarily. It'll be 8 because of 14 minus this. Yeah. So I'll just highlight the stuff here. It's this minus these. So that's how I got 8. I won't highlight the 8 right now because it's gonna move when I start typing. Can someone give us an answer there? What is it, like 12 something? Okay, 12.6 it is. Okay, so then the perimeter is equal to L plus S, which is, add those two numbers, is 50 and change. Awesome. All right, so hopefully that wasn't too dangerous. Let's take a look at one last question involving a portion of a circle. What's the weight? Norris, talk to me. I just made those up. Norris. You don't have to say that at all, okay? This L and S, I'm just giving these names. I don't care if you give those names, okay? So like linear portion, I just like using the letter L because it's the word linear. Like I'm not trying to confuse the issue here. Yeah, sorry. Yeah, no. Don't use those letters at all if you don't want to, okay? Sorry, I'm not trying to be cool or anything. I'm not trying to be cool here. I'm just trying to label things in the event that we get some really weird looking questions later. Anyway, but your question I'm sure is helping someone else too, so that's good. Let's move on here to, oh my goodness, what? How do we do this on the calculator? So, what part of it is the issue? Let's see here. Are you asking about this thing here, Cosmo? Okay, so do you know where the pi button is on your calculator? So you can do 8 times pi divided by 2. Literally how I said it. I'll type it here. Yeah, because, oh, you were trying to do a minus. Yeah, it's always adding. It's always adding. And that's what the hint is here, Tamerlan. See, never subtract edges when doing perimeter. Always keep on adding things. It's like when you go to the grocery store and you're buying things, you're always adding more. For the calculator thing, I would do this, just to mention Cosmo's question. I would do 8 times pi divided by 2. That's what I would type. You're most welcome. Okay, this is a bit of a mess. We have this funny looking shape. Let's give that a zoom. It needs some love. Let's give it some love here, okay? So we're trying to find the perimeter of this disaster. It looks very much a little bit more challenging than the other questions. So upon quick inspection, I noticed that there is a semicircle here, and there's a semicircle here. It's inside and outside diameters. So those two semicircles, we have the diameters, so we can actually find those very fast. We can find those really fast. Good morning, Sanjit. So let's do that. Let's do that right now. Instead of using funny symbols, I'm just going to write things in words, I think. So we'll say here that outer the outer part, if you want, the outer semicircle. Just be creative with what you write, but I'm not trying to be too weird with you. The outer semicircle is pi d over 2, and the inner semicircle is also pi d over 2. I will catch up to you, Nicholas. Thank you. So pi times 15 feet divided by 2, and pi times 8 feet divided by 2. Okay, so I'm going to deal with those two now with you. So pi times 7.5. So that's the first one there. We got that one now. So that's 23. I'm going to put extra decimals here. Okay. Are there any questions about those two formulas? Are there any questions about those two formulas? Let me know in the chat. Okay, so see, the outer semicircle is the purple one, and the orange one is the inner semicircle. So that's 12.57 as per Nicholas. Thank you. So now, have we found everything? No, we need a couple more lengths. So anybody want to tell me, or the class here, what's this length here? This guy right here, just this. How much is that? Okay, well, we'll figure it out together. We'll figure it out together. How much is this? What's that length in blue? How much is that length in blue? Let's just take one thing at a time here. How much is the blue length here? 7.5. That's correct. This is 7.5. Thank you, Tamirlan. And how much is this? 4. So those numbers are going to be the radii, okay? So these are radii. This is the radius and the radius. So this number here is 3.5. So whoever said 3.5 is correct. James, 7.5 is half of 15, and then 4 is half of 8. That's how we got them, okay? Yeah, exactly. Thank you, Sanjit. Exactly. So that's one way of doing it. If you want to deal with diameters, there's a secondary way of doing it, and I think it's the easier way with how Sanjit is saying to do it. So let me show you a cheaper way this time. This is 15. This is 8. So if we want to find the green length, we do 15 minus 8 divided by 2. Or in other words, exactly what the formula was as mentioned by Sanjit. Outer diameter minus inner diameter divided by 2. Norris, what's your question?
Okay, so remember how you said it was 7.5? So,
Yep.
like, when I did 15 minus 8, I got just 7. Like, I got the answer to 3.5, but if I did 15 take away 8, I only got 7 versus you guys said 7.5. I think you guys said it was.
So the 7.5 is something else. The 7.5 is if you take this number and divide it by 2.
Oh, okay. Okay.
Okay, so let's do it this way, okay? The
I
thing in green is the correct form. If you do 15 minus 8 divided by 2, the answer is 3.5 eventually. But instead of doing that, you could do this instead. You can do 15 divided by 2 minus 8 divided by 2, which is what my diagram was saying. So in other words, if you did it that way, you would have 7.5 minus 4. So you see how you get the same answer two different ways. The first answer, oh, you're welcome. The first answer deals with diameters, and the second answer deals with radii. They're different. I'm sure there's basically two types of groups here. That one group of people is trying to do with diameter, and one is trying to do with radii, and I'm just trying to satisfy both. So I'll just say here the linear segments, the linear portions, if you want. Well, it's going to be 3.5 feet plus 3.5 feet, which is 7 feet. As per, because there's two of them here. There's one here and there's one there. So the perimeter ultimately is going to be this. I got 43.1. Thank you, Nicholas. Okay, so anyway, that was a nice little icebreaker. I mean, I wanted to spend the first half hour just kind of reviewing, and the questions aren't as nasty as they look. It's just I don't want to just gloss over them with you. And I don't want to just say to you, "Oh, just do these questions and then we'll start on section 2." I've seen that happen in the past, not with me, and I'm not really a fan of that thing. So anyway, I hope that you appreciated this little intro and got you back up to speed with units and all the different small details that doesn't really matter about what specific chapter we're working on. Let's move on now to areas. So this will be what we'll spend the remaining time this week on, which is just calculating areas. If there's one thing that I hear from professors in other semesters, in terms of your program and all the programs that I'm involved with, it's students need to practice measurement and calculations of areas and volumes. So that's why we're spending a lot of time on calculation of areas, at least in this week's class. So there's various shapes that you're responsible to know in terms of this course. I'll just kind of briefly check them off here or just touch on them quickly. I've already highlighted this document, so if you go through this later when I post it on Blackboard, you should catalog. I would recommend on a single sheet of paper, just write down all the shapes and the formulas, because I'm not going to tell you before the test, oh, you should know the area of a rectangle. It's in the booklet, and I've already highlighted it for you. So yes, rectangles and squares. You need to know the area of a rectangle, length times width. Triangles. The area of a triangle, base times height divided by 2. So you should know the area of a triangle. The author then gets into a discussion about some more finer details about triangle areas. But in any case, I'm going to keep on going here. The third type of shape that we're going to deal with is circles. Area of a circle is pi r squared. Of all the formulas involving circles, I believe this is the one that students remember the most, is the area of a circle, pi r squared. But of course, and it's mentioned here, do not confuse it with the circumference of a circle 2 pi r. How do you know which is which? Well, area, yeah, exactly, yes, Nicholas. How do you not get confused about which formula is which? Remember that r squared is an area because it's squared. Like for example, when you say meters squared, you know that's an area. But when you just have r is a length. So length means that this formula is also a length. In other words, it represents the perimeter and not the area. Sometimes you don't want to deal with an entire circle. You want to deal with just part of a circle. So that's what's called a sector. So there's a sector. So where would you see a sector in everyday life? Well, if you ever seen a building that has a curved portion to it, and you wanted to calculate the square footage of that curved portion, the area of a sector is a very handy formula to use. Sectors are very common just because circles are very common. The formula for the sector of a circle, if you know the angle here in between, in degrees for example, then the area of a sector is given by this formula. Where did it go? Right here. This formula is really important, okay? I can't draw a star, but I assure you this is a very important formula. Theta divided by 360 times pi r squared. You can jot this one down now. When we do questions later, I will refer to the formula. I will write the formula down for you in the given question because I don't expect you to remember it immediately when you just saw it today for the first time, possibly. One last shape to talk about, and I think after that, well, there's two more shapes, but one of them is more familiar than the other. This is the trapezoid. So a trapezoid is a very good shape for you to know. And here's the shape itself. So the formula for the area is you take the top and the bottom, you take these guys here, and you average them. See how they're being averaged here? That's an average. And then you multiply your answer by the height. So essentially, you're turning it into a rectangle. You're essentially turning this figure into a rectangle. And the rectangle, the height of the rectangle is the same, but the base of the rectangle is the average of those two values. We're not going to see questions with all these shapes at the same time initially. I'll start off with easier ones and then we'll build up to weird ones later. Last shape here is one that you should be familiar with, and that's why I said there was really the trapezoid was the last weird one. This is the area of a parallelogram. So the area of a parallelogram is simply the base times the height. You can effectively turn this into a rectangle. If you're not sure how that becomes a rectangle, I can show you right now. If you take this shape right here and you put it over here, like you just move it over there like transplant, then you turn it into a rectangle. So that's why the parallelogram formula is so elegant. Base times height. So anyway, hopefully I didn't overwhelm you with a lot of shapes. The ones that really stick out are the sector and the trapezoid in terms of the ones that I would be, as if I was in your shoes, those would be the ones that I have the least practice or familiarity with. So when we take a look at the exercises, there's a whole bunch of exercises here. If you look on the side tab here, do you see all these shapes and colors? Look at that. So look at this. We have some rectangles, some triangles, some compound rectangles and triangles. The next page, we have some trapezoids. We have some irregular shapes here. We have triangles within triangles. triangles within rectangles, portions of rectangles missing, and then it gets into curved figures like radii and cross sections of circles and circular shapes, rectangles and circles that have been cut out, semicircles, and eventually you get into these funny looking figures where you have shapes that have portions removed related to circles, rectangles, and triangles. Now, there's a lot of shapes here. And it says 23 questions, but it's more like 40 questions. Our goal is not to do every single question. That would be absolutely draining for everybody. So what I've done is I've sampled, and you can see on the side here, I've taken out 1, 2, 3, 4, 6, 8, 9 questions. And we're going to just try to do as many of these questions as possible in today's class. Anything that's left over, we'll leave it for Friday. Also, in the before we finish the week, there is a small subsection here with additional questions. So these questions here that are highlighted on the side, I'm going to try to do as many of them as possible with you today and then Friday if necessary. So let's just start off by doing a couple of questions and then we'll take a break. So we're getting close to that time where I figure you have a well-deserved opportunity for a break. So this is your first question, and it's just question 1B. So for those that are not sure what page we're on, I'll just say again, we're talking about page 12, okay? So this is page 12. I've just kind of chopped out some questions here. So I'll just say that on the side here so everybody's clear. We're on page 12. I'll say pages 12 to 14 because it's really just a span of several pages. Find the area of each of the following figures. Okay, anybody have an answer to number 1? Okay, I'm a very, very mean person. I'm a very mean person. Why? Can someone tell me why I'm a mean person? Ah, why am I mean? Why am I mean? Area is length times width. No debating that with you. No issues there. Not very nice of me, the first day back in class, and I'm already giving you like cheap questions. The length is 2 feet, but the width is 8 inches. Exactly. See that? That's so mean. Thank you, Tamerlan. Sorry, that's not my fault. I'm gonna blame the author on that one, and I'm sure he's laughing if he hears this. But yeah. See the exclamation mark? Whenever I will go through these notes and I see an exclamation mark, I know it's a dirty play. So let's turn those into inches. So that's 24 inches by 8 inches. And thank you for that, Tamerlan. Yes, that's now when you write your answer, you can't put inches. You see what you're doing there? You put 190, what was it, 192? You can't do this because that's not inches squared. You need to write this, okay? You need to write that or you need to write square inches. Pick one, but do not put this symbol because it's not an area. This is a length. I'm not picking on you too much. I'm sorry. It's just this is something that a lot of students do. So I want to make sure that they communicate it better. Well, that wasn't very nice of me for the first example. Hopefully the next one I back off a little bit and it's not as mean. So I'll just scroll up here. Oh, this one's even funnier. Try in your head. So you're supposed to do this in your head. I'm not a fan of doing things in my head in front of an audience unless I've had my coffee. And right now I've only downed about 5% of the coffee. So we need to take a step back here and maybe write this down on paper. Is it okay if I scroll down? And let me know in the chat if anybody needs time to write this down up here. Thank you, Norris. Okay, I'll scroll down. I didn't hear anybody object, so let's go down here. Let's number these shapes. Here we go. You don't have to number things. I just like to number them because it makes my life easy to talk to you. Communication is so key when you're doing these questions, especially with all these compound shapes. So, area 1, area 2, area 3, area, you guessed it, total. So that's the kind of way that I would lay out these questions. Just put them all down, put your chips down on the table. There you go. Area 1, what shape is that? What's 1? Is that a rectangle or a square? What do you think? Rectangle or square? Rectangle. Thank you, Sanjit. Rectangle length width. The length is 1 meter. Thank you, Cosmo. What's the, sorry, the length is 1.2. Yeah. And that's 1. So that's equal to 1.2 meters squared. Ah, nasty, nasty, nasty. Okay. What is the area for 2? What shape is 2? Is a triangle. Half base height. Or is, I think it, or we also had another way of writing it, but that's the way that I like writing it. You can also write it like this. You can write BH over 2. Both of those are nice. This one's actually easier if you like dealing with the fractions immediately. I like to put the fractions later, so that's why I put it on the side. So the base and the height. Base and the height. So the base is 0.6 and the height is 1. Remember, with the triangle, you're looking at it sideways. So the height of the triangle is sideways. So if you do that there, what's that? Can someone confirm 0.3 meters squared? Any confirmation on that? Who agrees with 0.3? Cool. I'm going to copy and paste that for the third one, because even though these triangles look different, they're not the same triangle. They're not congruent. They are the same area because they have the same base and the same height. So we can now do the answer here. So 1.2, 0.3 plus 0.3 is 1.8. And that was question E. Put 1.80 here anyway. I like 1.8, but I just checked the answer key to make sure, and they want 1.80. They want 3 significant digits. We're not going to argue with them. So that's all I have to say about that. I think we should do one more question if that's okay, everybody, and then we'll take a break. I promise after the next question, we'll take a break. The next question is a trapezoid, and I just thought it would be a good opportunity just to talk about trapezoids because it's one of the weirder formulas for people. So here's your trapezoid. That's the formula. And the only thing you need to really get straight in your mind there is what the oh, thank you, Tamirlan. That's the, I think that's right. That sounds right. It might be 30. No, it's 60. You're right. I apologize. 60 is a good answer. Thank you. So in this case, the two values are 12 and 8, and you're averaging them, and then you're multiplying it by 6. What does A stand for again? I will mention that in a second, James. So A and B are as follows. A and B are these lengths here, these two lengths. It doesn't matter which is which. It doesn't matter which is which. The issue is that they're uneven. And what you're doing is, in this part of the formula, I'll highlight it in blue. In this part of the formula, you're taking the two numbers there, 8 and 12, and you're averaging them. So effectively, what you're doing is turning this shape into a rectangle. So this thing that I highlighted in blue, if you clean it up, it's 10. That's 10. So what you're doing is you're averaging the two upper and lower lengths into a single length. So this shape here has the same shape as a rectangle that is 10 by 6. How did you figure out that it was 10? Because if you do this part of the formula here, this part of the formula here is 10. See? Half of 12 times 8 is 10. 12 plus 8 is 20. 20 divided by 2 is 10. The cheaper way is this, Cosmo. Give me a number. Give me the number that is you're welcome. And this goes for everybody else, not for Cosmo, but someone else had a question too. Give me the number that is halfway between 8 and 12. What number is halfway between 8 and 12? And the answer is 10. So for this reason, if you can just say what I said as an exercise like that, give me the number that's halfway, then you can do trapezoids in your head. You can do trapezoids in your head if you know that. Because effectively what you're doing is just smoothing it out. You're just smoothing the shape out. So we're looking to find the area of the walls. So there's 4 walls on this room. The 4 walls of the room are going to be 2 of them the same and 2 of them the same. So let's just number them and deal with them separately. So we have the front wall and the back wall, which I'll call 1 and 2. And then you have the 2 side walls, which are 3 and 4. So if we find out what the area of the walls are, that'll give us kind of a building block off which to find the rest of the question. So what I would do is find the area of the walls and then subtract off the cavities that are from the doors and the windows. So find the area of the walls. And then deduct the area of the doors and windows. So hopefully that strategy is clear. The area of the walls is going to be 4 areas. So we can write down those areas briefly here. The area of number 1. So what's the area of the first wall? Can someone let me know in the chat? 180, thank you. Once we're done this calculation, I'm going to show you how to do this faster because this is too slow. That's the area of the first wall. It's also the area of the second wall. But the third wall is different area. It's going to be 12 by 10, which is 120. And then the area of the fourth wall, thank you, Marco. And the fourth wall is going to also be 120. This is too slow, by the way. But I'll just do it this way to start. So the area is going to equal, add those up. What do you get? 600? Thank you. So I have a comment about that because this is too much work. I'll show you how you find the area of the walls of a room, especially if you're looking at a blueprint. So this is how you find the area of the walls of a room, okay? When you look at this room from above, what do you have? You have a rectangle. And that rectangle is 18 by 10. That's 12, sorry, 18 by 12. Does that make sense, everybody? The area of the rectangle is 18 by 12. When the dimensions are 18 by 12. When you're looking from above, so this is the plan view. This is your plan view. Can someone tell me what the perimeter is of this room? What's the perimeter of this room? What is the perimeter of that room? Any volunteers? 60. Good. It's 60 meters. Whenever you want to find the area of the walls of a room, the area of the walls is the perimeter. Thank you. Thanks, Nicholas. The area of the walls of a room is the perimeter times the height. So I'm going to go back here and just mention that. The perimeter of the room is 60. The height is 10. 600. You see that? That's the cheap way. This is the way that you wanna do these questions, especially if you have a room that's really complicated. Like if you have a floor plan of anything. Let's say that you have your home, okay, and you have if you're living in an apartment or a condo or whatever, for example. Like I'm in a condo. If I wanted to paint my condo, what I would do is take the floor plan and I would just count up all the lines that make up the perimeter, and then I would multiply by the height of the condo unit, which is 9 feet or whatever it is, and say, okay, that's how many square feet of wall I have to paint. I'm not assuming that you're not painting the ceiling, for example. So you see what I'm saying here? There's a shortcut for the area of the walls. I'm just going to put that out there because I don't know if anybody has told you that yet. And if they do, it'll probably be in an estimating course. So I might as well just tell you it now. But anyway, to answer the question, we need to subtract away some information because there are doors and windows. So this part's just quick now. So we know the area. Yeah, the lateral surface area. Thank you. Thank you. Thank you. Thank you, Tamerlan. Have you seen that in the course already? Have you seen that formula in another course? Oh, in your high school. Gotcha. Thank you. Just making sure. Some professors will do that. That's why I don't want to take away from their course as well. The area of a window is 3 by 2. I'm just doing some quick math here with the door and a window. So the area for the doors and windows is going to be, well, there's, let's see here, there's 2 doors, so it's 2 times 21. And there are 4 windows, so 4 times 6. So 42 and 24 is 66. Someone confirm? Thank you, Marco. So final answer, 600 minus 66 is 534. I'm just checking it against the answer key. That's the right answer. So that was exciting. A question without a diagram that ended up having more calculations than any of the questions with diagrams that we did already. So just because a question doesn't have a picture doesn't mean that it's a walk in the park. You most certainly have to do pay extra attention to these types of questions because they're very deceptive. All right, I'll give you another 30 seconds or so to take down any information off this diagram that you need, and then we'll move on to the next question. Okay, hopefully that was too dangerous. Let's go to question number 9. we haven't seen a triangle in a while, so at least since the previous hour. So it says here that you want to find the area of the remaining quadrilateral. So you want to find the area of this region here that's not shaded. So there's a lot of writing here. Maybe we can zoom in on that and see what we can do with that. Hopefully that's a bit larger for you to read. So the question is to find the area of the unshaded region. The author here has written down a couple of areas in labels. I'll just label them for you as well. They call this here A, and they call this here B. Any suggestions on how to find the area that's in white, unshaded? What do you think? Let me know in the chat. So what are we going to do? What do you think we should do? I have a feeling some people are doing calculations. I just want to know the method. I want to know a method here, please. Okay, well, I'll start you off with a hint. You can find the overall area of the triangle. That's right. Thank you, Sanjit. So find the overall area of the triangle and then deducting the area of triangles A and B. I'll just say A and B. So let's find the overall area and then work from there. So I'll make a list of calculations below. So that area is going to equal half base times height. The base of the large triangle. What is the base of the large triangle? What is the base of the large triangle? Anybody? 15 is correct. You take the 11.5 to the 3.5. Thank you, Norris. And then the height is 8.5 on the left there. So if we do that, we get 63.75 square inches. Okay, let's find the area of the area A here, this triangle. So the area of triangle A. Okay, triangle A. We have a base and a height there. I'll highlight these ones. These ones are a little bit funny. So here's triangle A. We could use that as the base and that as the height. Yeah, 7.5 times 4 divided by 2. Yeah. I didn't check the answer yet, Tamerlan, sorry. 15, thank you. And repeat the same thing for triangle B. I realized why everybody was quiet there for a bit, because they were doing calculations. So thank you for working ahead on that. All good, Tamerlan. So for that little triangle there, it's 3.5. Yeah, that's the right answer, Nicholas. I agree with you there. That's half by, and then we'll have 3.5 by 2, which is just 3.5. So if we just find the net area now, we're good to go. So the final answer here is this. It's 63.75 square inches. I guess I have to turn that into an equation. equation mode on my calculator. Final answer, anybody? And that's good with me. I'm just gonna round it to 3 sig figs. I think they want it in 3 sig figs. That's okay. So we're subtracting those, right? Yeah, minus. So I think it's 45-ish. Anybody got like 45 somewhere there? I'm trying to do it in my head. I'm kind of slow today. 45.3, I think, is the answer to 3 sig figures. Can someone confirm? Thank you, Luca. Okie dokie. Thank you, Nicholas. There we go. All right. So hopefully these are not getting too annoying. We're going for quality here, right? Not quantity. So I'm gonna pick and choose a little bit now because I do want to cover sectors as well. So I don't see any sectors yet, which is kind of annoying. Let's keep on going here actually. This one here. Just trying to squeeze that in. Okay, find the area of this template. Well, that looks kind of exciting. All right, so I just kind of zoomed in the figure a bit. So any suggestions on this one? What would be a really fast way to answer this question? What's the fastest way you could answer this question? I would say it's as follows. The area of a rectangle minus the area of a circle. And you might say, wait a second, John, wait a second. It's not a circle. It's a semicircle. But the thing is that those two semicircles are the same radius. See this guy here and this guy here, they form a single circle. And that single circle has a radius of 2-inch radius. So I'm just taking advantage of the fortune of this question. It's just lucky. And I'm not going to play those tricks with you all the time. But if I have the opportunity to cut corners, I'm not being lazy. I'm just being smart, right? And hopefully that's something that'll rub off on you, and you'll find little tricks like that as well. So the rectangle is going to be 24 by 8, and all the units here are in inches, so that's good. And then the area of a circle is pi r squared. So the radius of that circle is 2. So this 7.5 inches here is kind of useless, as with the 6 inches. Those are just telling you the location of the circle, but they don't tell you the shape of the circle. So if I were to erase the 7.5 inches and the 6 inches, you would still be able to answer the question. Of course, provided that the circles are within the rectangle and that the numbers do make sense. So you should be able to type all that in one step on your calculator. I'm going to look at the answer key this time. 179. Thank you, Cosmo. We are good to go. 179 square inches. Thank you, Nicolos. That is right. So, anyway, it's a neat little question, and it just proves to you that you don't always have to like chop it up into little figures. You can cut corners and play smart and get around that problem. All right, here is another situation where you can combine the two circles. You can combine those two circles. So that's what I'm going to do as well here. Just going to zoom in on that figure for you. So I would do it's the exact same math. It is actually the same math. If I go to the previous question and I literally just steal this, I can just steal this from that question and put it in this question. and just change it to a plus sign, I think, right? If I change it to a plus sign, I believe that we have the exact same strategy in hand here. The fastest answer here would be the area of a rectangle plus the area of a circle, because these two separate circles are semicircles. Sorry, these two semicircles form a circle. So if I change that to a plus sign, then most of this answer is recyclable. You see that? Okay, so I'm going to write down the radius of the circle, which is 1.4. But you're going to tell me in the chat there, what is the width of the rectangle? Because that's the weird one. This one's the weird one. What is that number? What is the width of the rectangle? 2.8. Thank you, Temerlan. That is correct. Yeah. You're going to do 2 times 1.4. You're going to get 2.8. Awesome. Yeah, I'm typing this one out. Can someone confirm 25 approximately? How did you do to get the 2.8? Thank you. 2.8, I did 2 times 1.4. So this is 1.4, that's 1.4. So that's how I got 2.8. You're welcome. So that is 25.2 units, centimeters squared. Let's not forget the units. Oh, it looks like a K. Here, let me hide the evidence. There. Yeah, the a lot of these questions come from different sources in trades. So a lot of times when you're doing like machinery or tool and die, for example, you when you want to write a radius, you just put an R there to say radius. But I had to get used to it as well when I started teaching here, because I'm coming from my background's in engineering and in aerospace specifically, and I didn't really deal with too many circles. I was doing more physics stuff, so I wasn't really building anything of this nature. So let's talk about the area of a sector of a circle. Area of a sector of a circle. This is a big one. It's a big question. So I mentioned the formula earlier. I'm just going to mention here as well. We're doing 22b. So this formula is one that is the least familiar to people probably. Area of a sector of a circle is equal to pi r squared. Okay, if you had a circle, the area is pi r squared. But if you don't have the entire circle, then you have a fraction of a circle. And the way that you would say it is you'd say, well, whatever fraction of 360 my angle is, that's what proportion of the area I have. So in this case, if you look, the angle is 220. So this formula here is super, super important. But for that reason, I'm just going to highlight it again. Just a second, people. Sorry. You'll very rarely see me highlight a formula, but you know when I highlight something, it's super, super useful. So sector of a circle is that. Now the angle subtended by the radii is 220, and the radius is 8 meters. It's not a difficult formula to use. It's just a matter of you being correct with writing down the angle and not forgetting the order of operations on the calculator. So it's like it's a short and sweet question. It's not meant to be like a hard question that way. So 220 divided by 360 times pi r squared. I'm doing it on my calculator as well. I got 123. Can someone confirm? It's as easy as 1, 2, 3. Thank you, Cosmo. It's as easy as 1, 2, 3. If only, eh? If only it was that easy. So anyway, there's your formula for a sector. There are different ways to measure angles in geometry. Degrees is the one that you're most common to know, the one that you grew up with most of your life when you're learning math. But I assure you that there are other ways to measure angles other than degrees. There's ones called radians, and there's also something else called gradients. Radians is another way to measure angles. And it's actually, if you wrote down the area of a sector of a circle with radians, the formula is a lot more elegant. But we're not going to be dealing with radians in this course. We're only going to be dealing with degrees. So if you're familiar with any alternative formulas or you look them up online or something, that's why you'll see different versions of this formula, and it just has to do with what convention the angle is being described in. So we're getting close to wrapping things up today. We've got another about 15 or so minutes. So let's keep on going here. So this is the last question that I picked out of that group of questions. Even if we just did this one last question, I would be satisfied with today's lesson in terms of what we covered. But that means that on Friday, I would probably have to do 4 more questions, which is good because these last questions on Friday, if we do them, they're going to be they're going to take us about 10 minutes or 15 minutes each. So that's a good a healthy budget for time. So this will probably be our last question today, and then I will stick around for students for questions because some students had emailed me and reached out to ask for some guidance on various things. So anyway, last question for today. Find the area of the shaded region. Wow, there's not a lot of writing there. Not a lot of numbers. What the heck's going on here, right? Let's zoom in on that thing. Okay. Find the area of the shaded region. What do you think? Let me know in the chat. What's your plan? What's our plan here? It's hard to talk about it without using like labels, but perhaps I can offer you a strategy here without using too many fancy words, okay? How about area of large circle? Let's call the area of the large circle A1. And let's call the area of the small circle. There's 2 of them, I understand, but I'm just calling them the A1 and A2 for now. And then say here the area, the shaded area, is equal to the area of the larger circle minus 2 smaller circles, and then divide your answer by 2. Let me know in the chat who agrees with this formula. Agreeing or disagree. Who understands this formula? What I just said. Awesome. Thank you, Nicholas. Okay. So if you don't like how I said it with the formula, just say it in words. Say it like this. Say, okay, I would take the area of the big circle and take away the 2 little circles. If I take away the 2 little circles, if I do big circle minus small circles, then I end up with this area here. I end up with whatever's in orange, this part and this part. So that's this area. This area right here represents the orange stuff. I'll reshade it because there's a little bit of a delay with my when I'm using Blackboard and recording. It really is sluggish with my stylus pad here. So that's what the orange area is, okay? And then I need to divide that orange area by 2. So that's why there's a 2 on the bottom, because I only want the left half of it. So hopefully that secondary explanation is helping you understand the formula a bit better. So the area of the shaded region is the area of the big circle. Well, we got to go back here now. What's the area of the larger circle? Pi r squared. And the area of the smaller circle, I'll reshade that later. The area of the smaller circle is also pi r squared. What's the radius of the large circle? Can someone let me know in the chat? What is the radius of the large circle? 9.2. Thank you, Nicholas. Let's get a number on that then. So we have 9.2 squared times pi, 26590. 26590. Okay, so we have the area of the large circle. Now we need the area of the small circle. Any volunteers there? What is the radius of one of these smaller circles? 4.6 is correct. That is an excellent answer. So for those that are not sure why it's 4.6, I can explain it as follows. You can use symmetry arguments. I'll just say this, okay? Everybody agree? This is 18.4. This purple line here is 18.4. Well, so is this. This is also 18.4. And if I want the radius of the circle, which is just this piece here, I would divide 18.4 by 4. I would divide by 4 there. So I'm dividing by 4. That's how Nicholas got the answer of 4.6 for the radius, where it ultimately has the same answer. So 4.6 squared times pi is 66.48. So going back here, or the 9.2 divided by 2. I like your argument, Nicholas. That's the way that I actually did it in my head as well. But the way that I showed it on the screen is for perhaps someone that didn't see that pattern. But I like the way that you did it. That's the way that I did it as well, in terms of just in my head. Okay, so we have the area of the shaded region. We're ready to go now. We just toss in some numbers. So we have here 26590 minus 2 by 6648. And divide the answer by 2. So I'll just do that on my calculator as well. What did you get? Any takers on that? Anybody else get 66.5? It's all good, James. So the answer is 66.5. Thank you, Nicholas. Now, I'm going to show you something absolutely hilarious, okay? This is gonna cook a lot of your brains. Your brains are gonna get really, really confused in a second. This area here, the shaded area is the same as the area of one of the little circles. Wow. The shaded area is the same as the area of one of the smaller circles. So hopefully that really, really annoys you in terms of trying to understand that. So I'm going to leave you with that. I'm gonna leave you with what I want with a question. Think about why that's true. Why is that true? And the answer is really comes down to right here. See this 4 here? So it has to do with the fact that you're using the symmetry of the numbers. Yeah. Anyway, I don't want to talk about this question in terms of too much detail because we've already answered it. And I also wanted to finish class a little bit early so people can ask me some questions. But I'll mention something here, okay? I'll just say it quickly here. I'll explain to you why it's like that, okay? The area of 1 is equal to pi r squared, sure. And then the area of 2 is equal to this. It's equal to pi, and then I'll just say r over 4. So it's r over 4 because of my diagram. If you look at my diagram, it was r over 4. And then that equals pi r squared over 16. And if you plug that into this formula here, then you end up with pi r squared minus 2 pi r squared over 16 divided by 2. And all of the stuff cancels out and cleans up nicely. And then you get pi r squared divided by 16. You see? That's why, okay? I did a little proof here. This thing in blue here, don't worry about it. I'm not trying to destroy anybody's morning. I'm not trying to mess anybody's day up too much. But if you're curious, that's why it works out like that, okay? See, the area of the shaded actually ends up being the same as A2, regardless of what the radius of the largest circle is. Actually, regardless of the dimension, sorry, I should say. All right, that's enough for today, everybody. I hope that I hope that you're kind of brushed up on your length measurements. We're going to continue with some extra questions next time, but the whole purpose of doing all these exercises this week is so that we can answer questions involving volumes next week. Thank you